All right, kiddos. So we're going to cover lesson 607 in this video. And before you watch the rest of this video, it is imperative that you review in lesson 607. See, we're in lesson 6.07, moles and chemical equations. It is imperative that you read and review pages 2, 3, 4, 5. Make sure you're always clicking on the little links and the activities that are available as well. 2, 3, 4, 5, 2 through 5 before you watch the rest of this video. Okay, so pause it now, read pages 2 through 5 in lesson 6.07, do the little activities, and before you move any further in this video, make sure you are fully aware of what is happening on those pages. If you are not, if you read something and you try the activities and it's still not setting in the old brain, you must tell me before you move forward with this video. But after you do that, come back, watch the video. So here we go. You can predict the mass of the product you will get when you know the mass of the reactants. I'm just reading the top line there. You can predict the mass of the product you will get when you know the mass of the reactants. So if you have a chemical equation, right? If you know how much lithium nitride you're starting with, then you can predict how much ammonia you'll get at the end of the reaction if everything goes perfectly, and you can predict the mass of the lithium hydroxide that will be produced at the end of the reaction if everything goes perfectly. So according to this, lithium hydroxide, I'm right here, lithium hydroxide is used in spacecraft to absorb carbon dioxide, which the astronauts exhale. To make lithium hydroxide, you react lithium nitride with water, and the chemical equation is right here. Lithium nitride, solid lithium nitride reacts with 3 moles of liquid water to produce a mole of ammonia, or that should be an S for solid, not G for grams. A mole of solid ammonia and 3 moles of liquid lithium hydroxide. It's important to know the amount of reactants needed to create a certain amount of lithium hydroxide, right? We have to make the lithium hydroxide to absorb the carbon dioxide, so we need to, know the amounts. Take a look at the example shown to see how such calculations are done. So if I click on this, I will grab a screenshot of our question, and it says right here, we'll grab that much. We'll put it on our drawing program. I don't need my Microsoft Store. There we go. Paste. And there's the question. Okay, so this is an official stoichiometry question. Doesn't get any more stoichiometric than this question. All right, so here we go. You are given 105 grams of lithium nitride. That's your given. 105 grams of lithium nitride. Don't worry about the excess water part. How many grams? It just means you have plenty of water. How many grams of lithium hydroxide can you make? So lithium nitride is Li3N, and lithium hydroxide is the LiOH, just so we know what we're looking at. Now, in stoichiometry, the very first thing you have to have, most importantly, is a balanced chemical equation. So that's why it says right here, is the equation balanced? 3 lithium on the left, 3 lithium on the right, so 3 lithium left, 3 lithium right, 1 nitrogen on the left, 1 nitrogen on the right, 6 hydrogen on the left. I have 3 hydrogen here, and then these 3 hydrogen make 6 hydrogen, so my hydrogen are balanced, and I have 3 oxygen here, and then 3 oxygen here, so my oxygen are all balanced. So yes, we have a very lovely balanced chemical equation. I'm going to get rid of all that mess. Okay, so the next thing you're going to do is write down what you're given, which is 105 grams of lithium nitride, and the unknown is how many grams of lithium hydroxide can you make if you start with 105 grams of lithium nitride, right? So we're starting with 105 grams of that, and we want to know, if everything goes perfectly, how many grams of lithium hydroxide are we going to make. Now, you can't go directly from grams of one substance, lithium nitride, to grams of another substance. Can't do that conversion. You have to use a middleman. So we have to first convert to moles of lithium nitride. From there, I can convert to moles of lithium hydroxide. And from there, I can get to grams of lithium hydroxide. So you have to go to moles first. Moles is the middleman. Without it, you can't do the conversion. So as always, X equals given over 1, 5 grams of lithium nitride. Make sure you include the substance. That matters. Time sign and a line. I need grams of lithium nitride to cancel, so it goes on the bottom. I'm trying to get from grams to moles of lithium nitride, so that will go on the top. Just going to follow my arrows. Time sign and a line. From moles of lithium nitride, I'm trying to get to moles of lithium hydroxide. Right? And then from moles of lithium hydroxide, I'm going to grams of lithium hydroxide. Notice what I put up here. From grams of lithium nitride to moles of lithium nitride to moles of lithium hydroxide to grams is right across the top. Okay, all I did was take what I wrote here and put it right across the top of my dimensional analysis problem. Okay, but I can't do any math yet. I need my units to cancel. So I have moles of lithium nitride here, right here. I need it to cancel, so it has to go on the bottom. Always diagonal to the right to get something to cancel. I have moles of lithium hydroxide here. I need it to cancel, so it's going to go to diagonal to the right. And now I'm almost ready to do math, but I don't have any numbers. So here's where the tricky part comes in. I know this one, the middle one here, this is the molar ratio. Molar ratio. That's the easiest conversion factor to fill in because all you have to use are the coefficients from the balanced chemical equation. So if I go look for lithium hydroxide, make that one pink. If I go look for LiOH right here in the balanced chemical equation, it's right there, and there's a 3 in front of it. So I just put a 3 here. And then if I go look for Li3N, which is lithium nitride in the equation, that's right there. And there's actually a 1 in front of it, right? It's just not written. So I would put a 1 here. So this middle conversion factor right here, this thing, is the easiest to fill in with numbers because you just use the coefficients from the balanced chemical equation. Now, the rest, I have to find molar mass. So, for example, 1 mole of lithium nitride weighs a certain amount. So I have to fill that in. Well, if I look at my periodic table, right, here's lithium nitride. I'll put this up top to give us some room. There's 3 lithiums and 1 nitrogen. So if I add that up, if I look at the periodic table, lithium weighs, why is that doing that weirdness? It's moving. There we go. Let's try again. Okay, so I have 3 lithiums. Lithium weighs 6.94 grams per mole, but I have 3 of them, plus the weight of 1 nitrogen, which is 14.007. If I add all that up, I get 34.827 grams per mole. Okay, so that number is the molar mass, 34.827 of, a mole of lithium. Now if I go over here to my final conversion factor, I have to calculate the weight of 1 mole of lithium hydroxide. Now, when you do stoichiometry, I know this is getting kind of messy, but let's see. this conversion factor here, right, this whole conversion factor here, you just add up the weight of 1 mole of whatever the substance is. This is always going to be a 1, and this is always going to be the weight of whatever this compound is, okay? And then this conversion factor over here at the end, same idea. This number here is always going to be a 1, and then this number here is always going to be the weight of 1 mole of that substance. So if I go to my periodic table, I have LiOH. I've got 1 lithium, which weighs 6.94 grams, plus 1 oxygen, which is 15.999, plus 1 hydrogen, which is 1.008. And so the molar mass of lithium hydroxide is 23.947. I just added up the weight of 1 lithium, 1 oxygen, 1 hydrogen from the periodic table. So let's cancel our units. I'm going to scroll down here and give you guys some more space to see this. Cancel my units. Grams of lithium nitride are gone. Moles of lithium nitride are gone. Moles of lithium hydroxide are gone. And the only unit I'm left with at the end is grams of lithium hydroxide. So now if I do this math, let me clean this up. All right, so now that it's cleaned up a little bit, it's still kind of messy for me. So I'm going to rewrite the actual problem so that it's looking a little better. So we have X, oops, I don't want to use red, equals 105, I just said no red, grams of lithium 3 nitride over 1, times sign in a line. I'm trying to get rid of lithium 3 nitride, so I got to go from grams to moles of lithium 3 nitride, and then from moles of lithium 3 nitride I can get to moles of my unknown substance, which is LiOH, and then from moles of LiOH I can get to grams of LiOH. From the balanced chemical equation, I know that the molar ratio is 3 moles of LiOH to 1 mole of lithium nitride. I know that 1 mole of lithium nitride weighs 34.827 grams. And I know that 1 mole of lithium hydroxide weighs 23.947 grams. Let me cancel my units. Grams of lithium nitride are gone. Moles of lithium nitride are gone. Moles of lithium hydroxide are gone. And now I do the math. So everything across the top divided by everything on the bottom, and you end up with 217 grams of lithium hydroxide. So you were able to calculate, right? You were able to calculate, given the fact that part of the recipe started with 105 grams of lithium nitride, you now know you can produce 217 grams of lithium hydroxide.